Rule 6 of indices. We're almost done then, folks. So, launching straight into this, then a to the power of 1 over n. If you see a fraction on your index, you should be thinking roots. So, you'll be looking at surds in an alternative video. However, for the purpose of this, we should be having a square root or a root sign around the a, and this is always the nth root of a. Now you might be thinking, what on earth that's about? You might have seen just general square roots. Technically, a square root has a little 2 there, just so we're lazy in maths, we tend not to put the 2 in. We might have seen cube roots as well, so it's the same sort of idea. So, some examples for us to try then. If I've got 9 to the power of 1/2, this is the square root of 9. Square root of 9 we know is 3. Those of you that have seen the quadratic videos know that technically it's plus or minus 3, but for the purpose of this video, the square root of 9 is 3. We'll just keep it at that for the time being. Similarly, here we've got 16 to the power of 1/2. Again, the 2 is on the bottom here, so it becomes the 2 on the outside of the root. So we're looking at the square root of 16. Well, we know that 4 times 4 is 16, so the square root of 16 is 4. Then we start looking to the cubic ones. So we've got to the power of 1/3 this time. So instead of a little 2 here, we now have a little 3. 27 underneath the square, so underneath the cube root this time. Now, this might not be as easy. You might not be as familiar with your cube numbers. So what we can do at the side, if we're unsure, is just write down 1 to the power of 3. Well, that's 1 times 1 times 1 is 1. 2 cubed. 2 times 2 times 2 is 8. 3 cubed, 3 3s 27, so 3 3s is 9 times 3 again is 27. Oh, we've got 27, that's the number we're after. So the cube root of 27 must give us 3. Well, that same logic, we've now got 125 to the power of 1/3. So we're not 125 yet, let's just continue this. 4 cubed. Well, 4 times 4 is 16. Times that by 4, we get 64. And 5 cubed, well, 5 5s is 25. 25 times 5 is 125. Oh, right, okay, that's the number we're after here. So if 5 cubed is 125, then the cube root of 125 must give us 5. So cube root of 125 gives us 5. Now this little method here, using the just working through your powers, works no matter what the power is. So if we look at 32, this times to the power of 1 over 5. In all fairness, very few people know the power of 5 series. Most of us have a life outside of maths. So let's just work it out properly. We've got 1 to the power of 5. Well, 1 times 1 times 1, doesn't matter how many times we times 1 by 1, we still get 1. Right, that's easy enough. 2 to the power of, try that again, 2. I can draw a 2. 2 to the power of 5. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again gives us 32. That's the number I'm after here, right? Okay, so this is the 5th root of 32. We just discovered the 5th root of 32 must give us 2. And similarly with 81 to the power of 1/4, we're looking at our power 4 series. So 4 goes there, 81's here. And again, most of us have a life outside of maths, so let's just do this manually. 1 to the power of 4, well, we've just discovered 1 to the power of anything, still 1. 2 to the power of 4, 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the power of 4, we know 3 to the power of 3 up here is 27, so timesing that by 3 again will give us 81. Right, okay, so the 4th root of 81 must give us 3. These look trickier than they actually are, and a lot of people see these kind of things in tests and exams and they freak out completely. Hopefully you've looked at this and thought it's not quite as bad. I want you to give this a go for yourself. Good luck.